Welcome to DAC, the Data Analytics Colloquium. Today, we're so pleased and honored to have Dr. Yuan to share with us about this very interesting topics. And before we start the topic and then the introduction to Dr. Yuan, and let me just briefly, introduce this deck to you, because if this is the first time you log in and to join us, actually the DAG or Data Analytics Colloquium is actually that started like 5 years ago, and then it's supported by National Zhongxin University of Taiwan, and then also University of Texas at Dallas, School of Economic, Political, and Policy Sciences. So this colloquium, we try to convince international scholars and data scientists for this online seminars or webinars, or even workshops sometimes that we have this actually try to do it online. And so this members of the colloquium will engage in conversations with those scholars. So I think this is a great chance and opportunity that we get we invite the top-notch scholars, and then also share all those up-to-date or the most recent methods that doing political science or policy sciences. So today we have Dr. Mei Yuan. So I will just let Dr. Carl Ho to introduce Professor Yuan. Carl.
All right, thank you, Peter. And hi, welcome to the Data Analytics Colloquium. I'm very excited today, and we have a very special scholar and coming to our talk. I've been thinking and trying to invite her, and until this year, I think, because she has been working very busy in Washington D.C. and Dr. Mei Yuan and has been a geography scholar since her undergraduate years, and she graduated from the National Taiwan University with a bachelor's degree and also master's degree there, and the best university in Taiwan. Then she moved on to study geography also in the State University of New York, Buffalo, SUNY Buffalo. And she's currently the Espo Smith Professor of GIS, which is standing for Geospatial Information Sciences. And Dr. Yuan has many accolades, and she's an elected fellow of the American Association for Advancement Science, AAAS, and the American Association of Geographers, AAG, and also the University's Consortium of Geographic Information Science, GIScience. And she has been in UTD for a few years, and before she was assigned, and she was picked up, and then become the program director at National Science Foundation, and in the area of human and environment and geographic science. And she's currently the editor-in-chief in the journal called the International Journal of Geographic Information Science. And she has been also supported by multiple granting organizations or agencies, NSF, NASA, DOD, now it's a DOW now, DHS, and Center for Department of Homeland Security, DOJ, DOE, NOAA, USGS, and NIST. And I didn't want to go through all these acronyms, but a lot of them are very significant data agency and also federal agencies. And she and her students are at the Geospatial Analytics and Innovative Application Lab. And her lab is GAIA, explores ways to understand the dynamics of people, events, and places, as well as some connection about brain health, spatial behaviors, and the environment. And they also investigate the learning mechanism taken by humans and machines to conceptualize, represent, and compute geospatial processes. Today, we are really privileged, and we can get her back from the National Science Foundation. Hopefully, they will not snatch her again, so we can keep her at UTD for a longer time. And she will focus on a topic and called spatial thinking in machine learning and artificial intelligence. I think I talked too much. Without further ado, allow me to introduce Professor Mei Yuan.
Well, thank you very much, Dr. Hong and Dr. Pan. This is intimidating opportunities, even though I'm very grateful to have the opportunity to share with my thought with this colloquium. But it's also very intimidating that to give a talk for mostly political scientists. My political science intelligence is pretty much below average. So I'm very helpful here to waiting for questions and comments and criticisms
Sure.
in my
Mm.
talk. As Carl said, that I'm a geographer by training, and I study Geographic Information Science, and the GIS term have been changed depends on which community we talk to. So from that background, I want to share with you some of my thoughts on machine learning and artificial intelligence, which have been permeated through a lot of GIS work and geography studies. And since GIS is a very methodology-driven science community, so a lot of our paper submitted to IGGIS, International Journal of Geographic Information Science, is full of machine learning and fancy math and complicated Greek letters. So through all that experiences and my own research projects, I have a sense of some fundamental ideas and that people can take to further improve their understanding of machine learning and AI methods, and then also from that understanding to advance and innovate a new machine learning and AI thinking. So that's the overall idea when I prepare for this talk. So let me just go ahead to share my screen now. And again, I'm really looking forward to your questions and comments in the end, because I really enjoy learning and listen to different perspectives, because that helps me grow and think about things different ways. So I hope that you can teach me something in the end when you ask questions and share ideas. Okay, so again, the topic is spatial thinking in machine learning and artificial intelligence. And the overall basic thinking is partly stimulated by this book, but also because my long history of training in geography. And this book, Barbara Tversky, she is a psychologist and specifically cognitive psychologist. Their study area is how people learn and how people think. And in this book, which is a seminal book in cognitive psychology, she argued that all thought begins as a spatial thought. When we move in space, when we interact with space, when we think about space, we all generate new ideas. And then later on, I will show you that actually a lot of scientists or learners, mathematicians, physicists, biologists, they use space to think, to stimulate new ideas. So when our actions in the world or in our brain really serve the foundation of thoughts. And why this is important for machine learning and AI? Because the thinking process is allow us to ingest large amounts of data and then make predictions after the algorithm process. So the algorithm itself have to have some sort of a thinking foundation, and that to allow the algorithms to get the data and make trend and make the prediction. And funny enough that the same brain structure where we have places and spatial features represented in the brain, and I will mention that a little bit later, and it's also the places that they store and represent events, people, temporal timestamps, and spatial connections and spatial relationship, and overall conceptual spaces that when human try to observe the world and try to make sense what is going on. So what is spatial thinking and why is it important? And again, as a geographer in 2005, the National Academy of Science in the United States, they have this particular studies to look at how people think spatially and how can we help our students think spatially. But why spatial thinking is so important? As you can see that when we were young, we will play this kind of, can you see my cursor? And you will see the like a block, kids play block to look at what shape and sizes and how to put the block into the right hole. And a lot of people like to play puzzles. And that is the basic spatial thinking. When we play puzzles, the first step is always find the edge pieces. Once you have the edge pieces in place, and then the internal pieces that easily to fall in the right places. And nowadays, a lot of our kids might not play puzzles. They play computer games. One popular game is Candy Crush. The Candy Crush is very much a spatial game. You need to identify patterns across the screen, and then to understand which block you should remove so that you will get a same patterns across the columns. And even for more higher level thinking skills like playing chess or playing AlphaGo, playing the Go games, it's all based on the spatial structures of the domain, which is a board, and then to come out with spatial strategy to be able to win the game. And that this kind of trainings from very simple infant game of block all the way to the chess games for a lot of teenagers enjoy, that really should try to help us to develop this kind of a mental rotation. And as some of you have taken the IQ test and maybe in the middle school, and most of the IQ tests will have a spatial component to it to understand how students can think spatially and then make that mental translations of spatial objects. So in the end, what the spatial thinking is really to look at the object itself, to understand the spatial behavior, to recognize spatial relationships, to identify spatial patterns, and make the spatial transformations and in a particular spatial context. So all this together form the foundation of spatial thinking. And in the science realm, that spatial thinking at the upper left corner, and that's how in 240 years BC, before Christ, to be able to estimate the size of the Earth. And they have to be based on the spatial geometric ideas about how the sunlights are going through different latitudes, and then based on the angles and the distance on the surface between two locations to estimate the circumference of the Earth. And later on, the biologists discovered the DNA. The discovery of DNA is very much based on the spatial structures that as they model physically to recognize that how elements should connect to each other to finally build the DNA models. More recently, at the lower left corner, that scientists that use the spatial connections among neuron cells to understand how the brain make connections and transmit the electromagnetic signals across the neurons. And in the bottom center here, and that is the when you build a robot, the robot have to be able to think about space and do spatial reasoning to be able to know how should they do and take actions in that space. And even more interesting, just very recently, there is a new frontier for biology. They call it spatial omics. The spatial omics, they really looking at try to understand how the cells are organized in space and how their organizations enable them to communicate, transmit signals and nutrients, and how that connection help them to or enable them to interact with each other to perform the biological functions. And even more, and there is another spatial thinking foundation for cancer research. I found it really interesting that they call it tumor geography. But if you read this particular paper, they really should more properly should be called tumor GIS, because what they have is that they based on the geographic information system data structure and mapping algorithm that to organize the tumor cells and then to see how the tumor cells and normal cell make connections and how the tumors that become worse or better in terms of their tumor ecosystem. And in this particular project, this is the Grand Cancer Challenge it's a collaboration between the U.S. National Institute of Health, NIH, and the UK Cancer Research Foundation, and they joined together to have this cancer grand challenges. And they actually try to build something, as they describe, like a Google Earth for cancer. And so when they adopt the Google Earth idea, they very much adopt the spatial construct and the spatial data structures, and then to project that to the cancer data and to understand cancer development, tumor growth much better. And then, they do find that this is one way to be able to help them to see solutions that they may not be able to see before, to understand the mechanisms that they not be able to understand before. And talking about Google, we all know that Google Map is and later Google Earth is one of the major products from the Google. The Google's mission is they want to organize all the world's information and make it accessible to everybody. We don't want to worry about the business side of Google. There's a lot of controversy, but focus on their overall mission is to organize the world's information. And we know that in the past, they have PageRank. They organize the world information based on the connections between different web pages. And they use the PageRank algorithm to identify which page is more important over the other on a certain topic. But people will question that why they build up to the Google Map. The fact that they develop Google Map is because a lot of our information element and people search for information are really location based. This paper by Michael Jones, and he was one of the key developers of Google Map. And in this paper, he talked about the importance of who, where, what, and when, and how. And he emphasized that the developer of Google Map is really use space as the organizing principle of information. And once you have a space as an organizing principles, the information does not stay alone by itself. It contextualizes in a spatial context, in a geographical context. So you can see how restaurants close to a movie theater, and you can see that how a neighborhood become more prosperous while the other neighborhood seems dying. What are the spatial context differences between the two neighborhoods? That one and the other have different pathways in their development. And in the paper, you also talk about 3 stages of information proposed by Whitehead about you have to have a romance about the things you want to learn. The romance means that you have to have personal engagement and attachment to the things that you would like to learn. And when you position information in space and contextualize with geographical context, then you provide the sense of a place and personal experiences that will allow people to more memorable and more engage with that information they look for. And the second stage is precision. Precision means that you really zoom in to learn the information, the detail and the gist, the essence of that information, and become a specialized. And that from the spatial context is really you look at the you first look at the regional, then you zoom into the local characteristics. And after you zoom in to really know about the local ins and outs, then you generalize to get to know the entire area, entire city, entire region again. And also he mentioned that a lot of information, addresses, point of interest, directions, travel routing, and traffic and popular times at different restaurants and different grocery stores, those are innately location-based. So use a spatial framework to to organize information seems very reasonable. And I read this book, Moonwalking with Einstein, some years ago. It really gave me a lot of interest on how we use space to really help us to learn. And in learning psychology, they emphasize 2 very important learning strategies. One is active recall. You have to, once you learn something, you want to find opportunity to recall that information you learn so that the neurons in your brain will be able to get the firing regularities so that you can, later on, you can retrieve that information even more easily. And space repetition, it means that I learned this today and I need to review it tomorrow. I need to review it the day after tomorrow. We don't want to be just learn something and then stop intensively. And rather than study something for 2 hours, it will be more effective to study 15 minutes and then today, and then studying 15 minutes tomorrow, but regularly spacing and repeat that learning process. And so why that is important? One thing is that as I mentioned earlier, our space cell system in our brain, which is in hippocampus area and entorhinal cortex, that same neuron cell record location is the same neural cells to record social construct, record basic primitive ideas. And so even our brain itself, it actually make connections that spatially and then link the concept together. That's why in the lower right corner, there is a study tool called mind map. The mind map try to mimic the neuron system, that how we can purposefully identify the basic concepts when we learn something and make connection of those concepts. So those connections we made on the piece of a paper actually reflect the neuron systems in our brain. But for this particular book, Moonwalking with Einstein, and it is a journalist, Joshua Ford, and he interviewed some of the World Memory Championship. Before I read this book, I didn't know that there is a World Memory Championship. What they did is that they have a competition. They give you a random stack of cards, poker cards, and you have to remember that cards in the same order. So it's very challenging because how we are going about to memorize that random deck of cards and then to be able to recite it in the same order back. And so in this book, when he interviewed all those memory champions, they find that they use space as their reference when they try to memorize those random cards. So here I give you an example. This is published in Cognition Journal. And the techniques actually is a very old-fashioned technique called memory palace. Or you think about a room that you're familiar with, and when you are trying to memorize a car, you're starting with the front door is ace of space, and you go when you enter the front door, there's a mirror on the side. That mirror show the king. So based on the pathways that you navigate through the house, and you try to memorize the random numbers or random cars along the route. So this particular paper in Cognitions, that they're not just giving that experiment, they're also looking at the neuron responses. They see that whether the theory about memory palace is also reflected in our neural systems, which the experiment seems to support that theory. So here, just state that the spatial thinking or spatial structure is actually a very important tools for human and later for machine to be able to ingest data, record the data, represent the data, and then reason through the data and eventually produce output. So now we look at what is the spatial thinking in machine learning and artificial intelligence. And this is a very simple diagram, just mentioned that, where we have a lot of data coming in, and in the AI terminology is called features. We have feature coming in into this black box, either is machine learning algorithms or artificial intelligent models. And then the model predicts something. And I think that very importantly that the machine learning and artificial intelligence, the model, the goal is not to explain something. The goal is always to predict something. So they make predictions. But what they predict, if it's a categorical data, they predict different classes. And if it's a continuous value, and they use the regression concept to predict what would be the best numerical values for this prediction, then conventionally we have supervised learning and supervised learning, reinforced learning, and self-supervised learning. So we were looking at how spatial thinking is ingest in the input data features or input data. Then we were looking at how spatial thinking in the machine learning AI algorithms. Then we're also looking at how the spatial thinkings are embedded in the prediction. So spatial thinking in data, that's the input features, are pretty straightforward, and as straightforward from geographer perspective. And we know that social, political, and environmental processes take places somewhere. So the place, the location is the key for a lot of the understanding those processes. And we know that the data have spatial heterogeneity. The population characteristics in southern Dallas is different from the population characteristics in North Dallas. And the political ideology will be different, and then political tendency will be different, even the environmental data in terms of air pollution concentration, for example. And then also, in addition to the spatial heterogeneity, we also have a spatial connection to talk about topology, how neighborhoods connected to each other. Are these two neighborhoods that adjacent to each other or disjoint? How the flow of information, how the people flow from one location to another. Where is the data positioning? Is in a desert or is in the urban area or in the rural area? The position of the data is also influence the nature of the data. orientation, structure, and complexity. I think the complexity is very interesting to me. The complexity have two interesting property. One is hierarchical. We know that the social systems naturally have a hierarchical structures, easily from the tribe to community to neighborhood to family to individuals. And as I don't know much about political science, but I kind of think that political science, political data have a natural hierarchical structure as well. And then the second important element of complexity is self-similarity. So even though you have a different level of structures, but each level similar to a certain degree to the previous level. And therefore the property from the lower level is constrained by the property at the upper level. Property at the upper level is supported by the property at the lower level. But anyhow, those are all the spatial connections that we're looking at when we try to ingest features and data into the machine learning models. And of course, all politics are local, and 80% to 90% of government functions and policies are geographically based. And then we have a different spatial representation of data, and we have different spatial resolutions that will influence the scale of interpretation and scale of processes and the shape of the outcome of the prediction or the topology of the predicted properties. And very important here is that traditionally, if we don't consider spatial structures or spatial thinking, that a lot of our machine learning and AI, we train the model, and we usually will split our input data into training set and testing set. But a lot of times that the randomly split the data are based on the random ID or random numbers. But we know that that doesn't guarantee that it also represents spatial randomness. And in other words, that if most of your test data randomly selected are from South Dallas, but then when you try to make model predictions that use the test data from North Dallas, your model is not going to do very well. And in geography, we always talk about spatial autocorrelation. If we do not have a diverse spatial sampling locations, that even though we have 100 samples, but in fact, the 100 samples really in reality only corresponds to maybe 20 samples because of spatial autocorrelation. And here just show you a very simple example of the city of Dallas. The population density, if you look at the tract level, which is at a larger spatial resolution compared to the block level, which is much smaller spatial resolution. And you see that the pattern is quite different. So if we use this as an input data to feed into the machine learning or AI model, depends on you feeding the tract level data or block level data, your output prediction could be quite different. And we all know that there is what we call scale effects. The smaller the scale, you pick up more local singularity. And there's also a zoning effect. This is quite, it's a big topic right now in the United States because gerrymandering try to really scrutinize the boundary of the election districts so that they can guarantee to have more Republican vote or more Democrat vote. And here I show you that why the spatial thinking is important when we fit in the data, and that the symptoms paradox. If we look at, we don't worry about spatial structure, all the data we have in terms of population density and housing prices. And you see that the general trend is the higher the density, the higher the housing prices. But if you consider the spatial structure, it's we find that actually all these points, the open circles are from, maybe making it up, from North Dallas, and then this solid circle is from the South Dallas. So if you look at it individually, the housing prices actually decrease when the population density decrease. So it just shows that it's very important before we use a machine learning model or AI model, we have to think about the spatial structure of data and then make sure the data is representative of what we attempt to test for the hypothesis. And other thing about spatial thinking in data is here is the crime. The crime you can base on individual census tract to look at the crime density in that tract, or use the square like this, the Dallas Mayor's Task Force on looking at the crime distributions in Dallas. They put a city into a quarter square mile by quarter square mile square across the city, and then calculate the densities within each pixels. But lately, we think that that actually create a lot of artifacts in this crime hotspot. So my student and I, Brent Dale, we developed a new way to looking at the hotspot. So in this figure here, in the 3D view, you see there is a vertical towers, and those are the individual crimes that over time and stay in that location and doesn't change. So in that way, that particular location is having crimes over and over again over time. And then you see there is a plume, like a smoke, around that tower. And that smoke is also aggregate a lot of crime events. So, and again, over time, so you can see that the smoke tilted upward. That means that it started with one location as a hotspot, and then it moved over time to the left of that smoke. And then so this we can see that there is what criminologists mention is the crime replacement theory. It's that you have a police that station have more patrol in a high crime area. You kind of push the crime to the neighborhood area. So you see the plume going up, move away. And that provide even more information about how the crime distributed over space and time in this particular area. And another example I show you here is also working with my students. We try to develop a machine learning model. We use UNet with convolutional neural network. We input is the three layers at the bottom, and then try to predict the artifact, the archaeology. They have different artifacts like the platforms, the cave, the little like basins or houses. They're all underground, so we cannot see it on the ground. And the A map is the ones that archaeologists that go through a lot of evacuation and then field survey to come out with. So what we did is that we based on the three bottom layers, we fly UAV to collect the data, and then based on the archaeological characteristic to figure out what are the input features that will help us to identify those sites. And then the B map on the top is what we predicted. And we find out that we have almost 96%, 95, 96% accuracy based on the machine learning model we created. And there are a lot of spatial thinkings that need to be considered when we use machine learning model and in terms of a data representation. A lot of you have done machine learning, you know that we have to scale our data, have to normalize data, have to transform the data. So all the input features will be in the same footing in a way that same the unit length will be the same and the range of the values will be the same. And without doing this, we will have one feature dominate the overall learning process, and the algorithm is not going to do very well. But then look, we finished the input feature part, and let's looking at the algorithm side of it. How spatial thinking help us to build the algorithms and evaluate the algorithm. And the easiest and very popular algorithm is called k-mean. K-mean use a lot, all kind of classification, spatial data or non-spatial data. But the interesting here is that when we apply k-mean, we convert non-spatial data into a vector and then project that vector to a multi-dimensional space, and each data become a data point. So the algorithm first randomly identifies 3 points, and then
受到不同的影响。
any problems? And then we will calculate the distance of our other points to that 3 randomly select points, and then group them. And then after we have the first group, we identify the centroid points and then calculate distance again, and then reiterate it to the point that there's no more change grouping. So the basic idea in the algorithm is really based on the distance in the multi-dimensional feature space, not necessarily in the geographical space. But the basic distance idea is very much spatially based. And then same as another popular algorithm called DB-scan, density-based clustering method. And it's the same, you identify and then you find the distance and then make the connections between points to identify clusters. But you will say, well, these are all cluster or point-based. That of course, the spatial thinking will be important, or the basic spatial concept will be important. But even for the UNet, that this is the UNet that I mentioned we used for the archaeology site mapping. That if you really go into the model architecture, it really have a downscaling element and upscaling element. The downscaling and upscaling element is really to looking at features at different scale and different hierarchy, how they piece together individual elements that form larger scale factors in the upscaling process based on what the individual elements and features identify in the downscaling process. And then if you look into the upscaling, downscaling, intermediate outcomes, and you can see that it is really zooming into the local and then expanding out to the region in terms of the overall architecture design. But then you say, well, of course, it's convolutional neural network. So the spatial concept is very much ingrained in the convolution idea. And then how about transformer? And large language models where is the spatial concept? But interesting enough, this paper attention is all you need. If you're really looking into the paper, the attention is really location based. So before we get into that attention, let's looking at the very first element of all the language model is really to vectorize words. Vectorize words, in other words, is how to spatialize words. And word is a categorical qualitative element. How can we make it into a vector so that the words will become a point in a multidimensional space? And if we make that vector, the coordinate, strategically identified, then we can do simple vector calculation or metric calculation to identify relevant words. So the very famous case is that the distance between king and queen is the same distance between men and women, and same as the countries and their capitals. But again, those relationship, those spatial relationship is not by accident. It's strategically to spatialize the words into the vector forms and then position that words in that multidimensional space to make it happen. Okay, so once we can put the words in as a point in a vector space, then a lot of the large language models and natural language process can take advantage of that to see how it works. But for the spatial thinking in algorithm in the transformers, they actually have a second step to really try to take the advantage of spatial thinking in the sequence of words in a document. So the input here is we have a space between one sentence to another. So my dog is cute, and then have a space that's separated to the next sentence. He likes to play something, play golfing or flying, and then have another space. So the sequence of the words and spacing of the sentences becomes consideration and a part of the attention in the transformers. So it will embed the words. So first line, the yellow line here is to embed the words like a word to vet, so that every word become a vector in that multidimensional space. Then the green line here is the segment of the sentences. So it record the sentence A is before the sentence B. So it embedded that location and positioning of sentences in the input document. And then the most importantly is really the third part here, is the positional embedding. So every word that embed the position of each word. So for example, the my, that words is at position 1, dog is at position 2, and so on and so forth. So those positions will be considered when we train the model. They also train based on the position of the words in the document. Okay, so once we have position of the words and we have the word itself, then the position of the words and the word itself will use to train the model to derive 3 very important values, Q, K, and V. Q means query. If I have a word, my, and my next word is dog, and I will go out to query that in the document, how many times that the word my is followed by dog. So in other words, that the my is at position 1 and dog is in position 2. And then we have the K to respond to that value of that, how important that position, how frequent that position is connected between my and dog in the position 1 and position 2. And then have a value. The value is also a trend by the model. It says that, well, when you have a my at position 1, dog at position 2, and then what will be the weight I can ask to use to modify the value of the overall importance that my dog is situated in this particular document. So the attention here, as I noted, is really the Q, K, and V to decide that when you want how much attention you should pay to this particular structure, my dog. And then this is a very simplified explanation about how the transformer attention work. But I think that my key point here is really that the attention is very much spatially situated, and then take advantage of spatial structure of the sentences and the statement and across the whole document to come up with to train the model to determine Q, K, and V. And then eventually the V is to tell us that how much weighted by the QK to tell us that how much attention you should pay to this particular sentence structure and positioning. And you can see here that this particular matrix, the upper part of the matrix have no value, which is have no attention values to it. The reason is that the large language model is always trying to predict the next word. So you cannot use the next word as your reference to make the prediction. So you always predict based on the previous words. So actually my example give you earlier is not really a good one. I really should use that my dog and then try to predict how likely that the next word is. Okay, and then once we have the everything in the vector form, then we can have a dot product to look at the importance of a particular word to another word, or cross product to look at what is their transform meanings out of it. And the spatialization we mentioned earlier is a word to vect is vectorized word or spatialized word. But in fact, in the literature, there are a lot of to vect. We have place to vect, we have word to vect, location to vect, GPS to vect. So almost like what you can think of, it can be to vect, census to vect, and then sentence here, community to vect, event to vect, process to vec, action to vec. So the basic idea is that when you convert everything to the vector form, which means become a dot, a point in a multi-dimensional space, that give you a lot of a new perspective. How can you do with it? And how can you generate new, make connection to other dots and then to calculate the spatial relationship among dots. And then in the model predictions, especially in GIS or geography, the Alpha Earth is really exciting, at least to me, is that over the years, we have a lot of satellite imageries. When we try to understand the land use land cover change, when we try to understand that why this particular area is more vulnerable to landslide, the other area seems to be less vulnerable. Why this location always have floods and the other location nearby seems less vulnerable to flooding. And then we use satellite imageries to help us to delineate, identify the surface property of the Earth or locations. But what Google have been doing is that they combine multiple years of satellite imageries from 2017 to 2024 and condense it and then make that into a vector and then tie that vector to every 10 meter by 10 meter location on the surface of the Earth. So that vector have 64 dimensions of the vector, every location, every year. So when we try to find how much change this location from 2017 to 2018, it's very easy. We just subtract these two vectors that we will find the differences between the two, between that location change from one year to another. So I have just started working on this and then try to use this data for human health analysis on one of my the the brain health project, and we'll see how it goes. And hopefully I can share with you some result years to come. And then, of course, there are a lot of spatial thinkings in model prediction. In other words, the model output itself are spatially referenced so that we can see how things change, are different, and classified in different ways based on different locations. And in other words, that is, in my opinion, spatial thinking is everywhere in AI and machine learning. I just look at the time. I'm sorry, I need to speak up a little bit. So I'm going to glaze over very quick starting here. So these are the list of what we think that spatial thinking have been really enrich AI and machine learning algorithms, data, and output. And from the Jason Huang, in one of his keynote speech on the NVIDIA conference, he argued that we have from perceptual AI, and those have a lot of speech recognition, image recognition, facial recognition. Those are perceptual AI. And now we are in the stage of generative AI, that the AI generate tokens, and the token can be pixels and can be words and can be videos. And so whatever we wanted to generate, we just design in a way that it will generate that token. And then we are starting getting into agentic AI that allow us to build assistants that to be able to plan, take actions, and achieve whatever goals that we request the agentic AI to do. And he thinks that agentic AI is provide the foundation to really realize a physical AI. That's the real robots that can interact with the physical world. And throughout the talk, he emphasized the importance of understand the physics and have a physics-based AI model and have the and so NVIDIA developed a lot of libraries to be able to look at how the light and then refractions and how to build 3D objects. But if you look at the even from planning, action, movement, interaction, they based on who and what, they all have to go through where and when to determine what to do. So in other words, that spatial and temporal are still the very much the connections, the references to make possible from generative AI to agentic AI to physical AI. And the contextual information and situational awareness is very very important to make successful agentic AI and especially physical AI. So there's a Fei Li. A lot of people know her that she is one of the pioneers in computer vision. And she emphasized that spatial intelligence is what we really are missing in the current AI development. And that speaks my mind. Spatial intelligence, for me, is very much spatial thinking, spatial behaviors, spatial cognition, spatial understanding. So she started a new company called World Lab. And the World Lab, her idea is that she wants to be able to create a large world model, in contrast to the large language model. The large world model would be able to create realistic world that be able to generate world so that we can interact with it. And the example on her company website is that you input a static image, it will create a 3D world based on that static image. And that's pretty cool, but I will argue that you've got to know about the geography, the sociology, the political interactions, the principles to be able to really generate in a world that is realistic and meaningful. And likewise, Google Genie 3, they already be able to, you give it a prompt that what kind of world you want, and it will generate a dynamic world that you can navigate through it in real time, and you can also interact with that real world, paint the world blue, and you come back, the world will be blue. It's almost like the real response in the virtual world. And then you, based on that, you can do a lot of experiments or simulations that to see how it might be. But all this, you find that throughout all the AI development, we now in last year, this paper showed that they use AI chatbot to do the tuning text. They find that the AI chatbot based on the personality test by psychologists, and also looking at their behavior on game, they find that they cannot differentiate, do they play with a chatbot or AI, or do they play with a real human? And they do the experiment with 10,000 more people across 50 countries. So it's a really large sample. But their conclusion is that the ChatGPT-4, based on the personality test through the gaming, they cannot differentiate is a human or is AI. And in other words, that the chatbot have passed the tuning test. And very funny in the paper, in my opinion, is that they find out that when the chatbot does have some behavior deviate from common human beings, and that behavior are usually more cooperative and altruistic. And when I read that passage, I said, gosh, what I have said about human intelligence, and do large language model really understand the world, and because they are more cooperative and altruistic. But the good news, at least for me, working in GIS and really thinking spatial thinking and spatial intelligence and spatial cognition is important, is that AI chatbot, there's another study that actually failed the spatial intelligence test. And the test is like this: you get a pattern, and then you it showed that on the top, four kind of shape block, and then you have two. Then you test, you get four, and what will be the result? And so AI failed this test. So in other words, that the AI still don't have spatial thinking ability, and that's good news to us, because in that way that the geographers, sociologists, and political science, we can really ingest the spatial thinking and spatial behavior into the AI intelligence. And AI have a lot of challenges to really try to understand what is our world, and really no, the world knowledge is really the social knowledge, this knowledge from social behavior and political sciences. So we have a lot of opportunity to contribute to the next advances in AI. And of course, for geospatial science, that's my discipline, that you really focus on how to understand world and how to acquire world models to really align with physical, biological, and social, and more important, human life ourselves. And I will skip this since the audience, most are political science. But anyhow, a lot of times that we nowadays we defer the tools and the work to AI. We spend a lot of resources and time and energy to train the model, how train the machine how to learn, while the machine is learning. But I'm afraid that a lot of humans stop learning, and software is become more intelligence, but human intelligence is much more questionable at this point. And when machine is getting smarter, do human become dumber? And nowadays, there are a lot of discussion about cognitive descaling. And talking about cognitive descaling, if you look at the Alzheimer's disease, 4 out of 10 early signs of Alzheimer's are related to spatial cognition. And I mentioned earlier that our brain have the spatial systems. We have place cells that record the location we have been visited. We have a grid cells that give out a coordinate systems that whenever we get into a location like a room, a arena, or a shopping mall. And we have a boundary cells that when we close to a particular wall or rivers or any kind of boundary construct, and those cells will get activated. So for this particular project, I work with neuroscientists to look at whether the more complex environment will have more opportunity for humans to exercise those space cells. And the excitatory effect on those space cells will also have a delay effect on the onset or slow down the Alzheimer's disease. So we will see how that work out. And that is the project that I was thinking to use the Google Alpha Earth data to looking at how the location differences that impact the human spatial cell activities. Anyhow, in conclusion, I think that spatial thinking is instrumental for from data processing to algorithm development to model output. And spatial thinking provide new conceptual models, conceptual framework, and new perspective to find solutions. And human right now remain outperform AI and machine learning in spatial thinking. And I think spatial thinking is essential to understand the world. And it's very important that we contribute to enrich AI and machine learning in the world understanding. And then finally, spatial thinking are very connected to cognitive functions. And make sure you exercise your spatial thinking skill in learning and in how do you frame the problems and also your daily activities. So you can exercise your spatial cell systems in your brain, and maybe you will get the benefit of delaying the onset of Alzheimer or slow down the progression of Alzheimer when you get old. Thank you very much. That's all I have.
Wow, it's a great presentation. Thank you, Dr. Yan. This is very amazing. This is something new to me. I talk to my students. This is something I'm eager to learn about spatial thinking concepts. And now I think Peter and I will start moderating questions and answers or posing questions. And maybe we can start taking questions now. Either you can put in a chat box, or you can just speak out, or you would like to relate questions to Peter and in Taiwan side if you're too shy to ask. So let me see. Peter, do you have any questions from your side? Then I will open up for questions on the Dallas side or Texas or US side here.
Okay. If you don't mind, I'll just start. Yeah. Well,
so if the students in Taiwan, if you would like to ask question in Chinese, I can understand Chinese and I can help you translate.
Okay. Yeah, I got one
figure out the
question
Chinese
here.
terms.
Yeah.
Yeah.
Very good. So, well, students, please, if you do have questions, you can use English or Chinese. You're welcome. And then I'll just start with one question because you mentioned about the world models. Well, actually, just recently, right? In the recent days, I don't know, Fei just kind of announced something. So about this world models, I was just wondering about the current progress or of that. For example, could you just share a bit about how social or the political context can be converting into vector representations? Because this is quite, if that's something material and or that we can tangible or that we can think of in real shapes, things like that, and then probably for a layman, I was thinking that one probably is easier for to convert into vector representation, but for context wise or social or like political, it's quite subtle things. Then how does that how do they convert that into vector representation? So in the future that we have the AGI or the the general AI. Probably they have to learn something about that so they can be, upgrade until some at some to some level. And well, actually, I hope that doesn't happen. But this question, I'm not sure if you follow. My question is not very organized. So, can you share a little bit about that? Thank you.
Yeah, I think that the AI advanced so rapidly, so it's a lot of time I have a hard time to catch up. It's just so fast. But I really enjoy doing this. And one way I try to keep myself in the AI conversation to know what is going on is I actually buy AI stocks because I am afraid to lose money. So I have to keep up with the latest development. And I did lose a lot of money regardless. But anyhow, I just say that it's really very fast pacing field. And in terms of the large world models, and yes, it just started in last year, 2024. And the Fei Fei Li's company is a private company. She gave a lot of talk on the web, but she never go into the technical detail. And some people ask her about the technical detail, how they do, or what's the direction they are going forward. And she was very reserved. I think that maybe because the competition is very fierce for
Yeah.
all the AI startups, so they want to keep their intellectual advantages. But what she has put on her website mostly is when you give a photo or still drawing, and their algorithm can base on that drawing of photos to construct a 3D virtual world out of it. And that's all she has as far as I can tell. And then so that will have a lot of assumption like, well, I know that from a static picture to 3D is not too difficult because a house is a house. Now easy to construct the 3D volumes out of a house, but we just need to have assumption that what it would look like is a standard shape and volumes, for example. So as of now, I haven't yet seen any revolutionary innovation from her World Lab company. But I do think that the Google Genie, Genie 2 now is quite exciting in a way that I can describe the type of a world I want. And then it's based on the natural language input. Then it's based on the narrative to generate a imaginary world, but they can generate it with certain degree of realism, like the river will flow. You will see the fishermen navigate through the canal, for example. But they do not have, at least I haven't seen the example that they actually look at how the social functions within that virtual world. They have individuals activities like go fishing, hiking, but it doesn't have, for example, and how a group of people may march downstream and then may have a riot happening. And something like to have a social activities. I haven't seen that in their demos, but it doesn't mean that they haven't yet done it. But it is my opinion. I think that without the input from social scientists, it will be really hard for them to really come up with a social realistic world. And and when I at the end of my NSF assignment, And our NSF at that time was really stressed by the administration to invest in AI. So we
Mhm.
actually have a quota, a different program. We have to have a certain amount percentage of funds to support AI projects. And
Mm.
so our program directors know almost every day when we get together, we're talking about how we can encourage our communities to either use AI to enrich their research or develop a new AI framework to come up with a new perspective, a new experiment, or new research design. And
Okay.
so I think that one thing they come out with is really important is human-centered AI. That
Mhm.
because a lot of social and behavior sciences,
Mhm.
you have to have the
Mhm.
human component to ingest the knowledge and construct into the AI model to make sure the AI, whatever it generated or whatever it predict, will align with what is our understanding of how the society function, how the geographical
Mhm.
system operate.
Mhm.
Yeah. Right. Thank you. And then we have some
Great, great.
questions, right? Yeah. In the chat box.
Yeah, and actually, I
Sure.
have some questions myself, but I will let the students and questions be posted first. And Ashley asked, what algorithms are best suited for spatial data?
What algorithm best suited for spatial data? Um, um, well, I wouldn't say which algorithms are best suited for
Yeah.
spatial data. I would think that
Hmm.
which algorithms are best for different type of problems. Because like
Yeah.
some problems are classification problems, so
Yeah.
clusterings will be a good
Mm-hmm.
algorithm.
Mm-hmm.
And as to spatial data, it is my bias. I think because in my opinion, most of the AI and algorithms, machine learning algorithms, spatialize the data. So if the
Mm-hmm.
data is not spatial, it spatialize it. So in that case,
Yeah. Mm-hmm.
all algorithms can
Yeah.
be,
Yeah. Indeed.
spatial data can be used in all algorithms. But whether the
Mm-hmm.
algorithm that the internal reasoning can produce the meaningful
Mm-hmm.
prediction, that's a different problem. I think it's more important that
Mm-hmm.
what are the nature of the problems and what you try to predict,
Yeah.
whether
Mm-hmm.
the internal
Mm-hmm.
AI reasoning support uh, to to support to have the minimal prediction in the output, and that is more
Mm-hmm.
important. But that will be depends on the nature of the problem.
Mm-hmm. Peter, allow me to follow up with that two other participants'
Yes.
questions,
Yeah.
and
Yeah. Go ahead.
so it's okay. Sammy asked, "Hello, Professor. What were the main challenges you faced when you uh, oh wow, it's more pop up now. First started integrating spatial thinking concepts with machine learning?" Then I have two more follow-up
Uh,
questions, and yeah.
okay. Well, I will respond in a way that
Mm-hmm.
I found my challenges of looking into machine learning and AI as I did GIS, the International Journal of Geographic Information Science. In the
Mm-hmm.
last 12 months, we have over 2,000 manuscripts submitted, and almost 80% of the manuscripts are AI or machine learning related. So a lot of my
Mm-hmm.
learning is really through reviewing papers. And then when I don't understand a particular algorithms, and I find the literatures and then study those algorithms. So those is the most challenging element for me, especially a lot of AI researchers like the acronyms. So it could be that one abstract will have five, six different acronyms. And then just to recognize what those acronym means is very challenging. And I also think that's the pitfall in my disciplines in a way that
Mm-hmm.
uh, a lot of GIS researchers, they are very mathematical savvy. And so they quickly ingest all the math. Actually, the underlying math is just algebra, metric calculation, and calculus one mostly. And so, and they add additional element into it. So a simple like a CN convolutional neural network, they will add functionally weighted or distantly weighted, attributely weighted. So they add a lot of element on top of the very simple model and make that model very complicated. So when I review those manuscripts, I have to understand what's the nuances in there. So in terms of challenges, my main challenge is really to understand the algorithms and how what are the novelty in those algorithms and how the novelty in the algorithms help us to think differently or make predictions that we cannot make prediction before.
Yeah, and then Gary has a question. I think it's a comment. It could be a comment. He said, "I'm afraid Fei Li's team may not have enough resource in exploring spatial effect with Moran's eye, kriging, etc." And I'll let you answer that. Yeah, too. Yeah.
Yeah, Gary, I think that's an interesting thought. If we can handle Marine's eye and kriging, I believe that Fei's group can handle it as well because they are very successful in fundraising. They have hundreds of millions of dollars to support their new startup. So in comparison, we in the academic have less resources, not the private startup company in many ways.
Let me also read out a question from a Korean participant, and thank you for coming. And Professor, let me read it out because some of you may not have the full access to the chat box. Thank you for your lecture today. I'm a student from Kyunghee University in Korea. I would like to ask a question related to what you mentioned. You mentioned that spatial environments are now being constructed in 3D, and there are many companies are using VR or AI to provide virtual tourism experiences for customers. In your view, can these virtual participants be considered tourists? Additionally, with this kind of development becoming more common, how do you think the tourism industry should respond or adapt? Thank you again for your insights. Yeah, interesting. Yeah.
Yeah, well, that's an interesting question in the way that virtual reality or AI generated 3D world or fantasy world, and they can be very invited. Like, for example, if I imagine that I'm in heaven and have unicorns or have a angel flying, if I can imagine, the large world model will be able to create that virtual environment, and I can put myself in the fantasy. I would think that I could be a tourist because the company create that virtual environment. I will pay for that experiences, and in that case, the tourist industry is not into the physical world, but into the world that whoever want to generate the fantasy world to visit that fantasy world. So it could be, I think it is possible to create a brand new tourist industry out of this. But also, I don't know anybody have tried the Google the Apple what they call the Apple headset. There are a lot of the 3D devices that headset you can use that, so you can actually make a tour in your own bedroom or living room, right? So and then people sell those devices and sell the algorithms to allow you to create that virtual world, whatever you can imagine. So in other words, I would think that the AI eventually, I am teaching an AI course this semester, and one thing I really ask AI to do this is that uh, AI is going. Everybody is afraid that AI is taking jobs, especially entry level positions, and a lot of people will worry that, well, when AI, physical AI in place, and do we have anything left for human to do? Or maybe just very few positions as a management position that human to do. And I always think that 10 years ago, we never thought influencer can be such a ludicrous position, right? There's no influencers. And
AOL.
5 years ago, there's no prompt engineer. But in United States, some of my friends that he is a linguistic professor, and at that time that they thought their linguistic students have a very limited job opportunities. Never did they know that the chat GPT come out. They are hired as prompt engineers and they make
Wow.
5, 6 digit salaries. So we never know what will come about, but we just have to prepare ourselves, know where is technology going and how can we prepare ourselves so when the opportunity comes, we will have an innovative idea to create opportunities for ourselves.
Indeed, indeed. I still have more questions, but let me stop here and let me ask Peter. And I think I want to check if you have more questions from your side first.
Well, I'll let one of our guests is from Taipei University.
Okay.
Yeah, and then
Let
he's
me
got
read
a
it out now.
question very specific. Maybe Professor Yuan, you want to have some feedback on that?
Yeah. And maybe I can read it again. And Professor, thank you for the lecture today. I'm a student from National Taipei University. I want to ask a question about issues when faced with complex models that simultaneously integrate vegetation carbon sinks, soil carbon sinks, and marine carbon sinks with land use, and considering the covariance, nonlinearity, and uncertainty of some natural factors in the analysis of spatially complex models. Would you, as a teacher, remind students to pay special attention to the selection and comparison of mathematical and geographical models used in analysis? Give an example to an OLS plus forest versus a GWR plus an SLM. Oh, yeah, SLM.
Well, how much time do you have?
Feature engineering now. Feature engineering. Yeah.
Yeah. Well, I think it seems like you have a pretty big problem, almost like capstone project or master thesis project. So I would say it this way. I know that you know a lot of methods like OLN or I think forest, you must mean random forest or
Rainforest, yeah.
Random.
geographically weighted regressions and so on.
Regression, yeah.
So,
Weighted regression, yeah.
yeah, so I would think that as a scientist, I think our ultimate goal is try to simplify the complexity. We don't try to make things more complicated than necessary. Just think about Einstein when he studied a very complex physics problem, but he came out with the equation E equal to mc squared, right? So it's a very simple, it simplifies the reality to a very easily understand and comprehend form. And that's what the science should do, scientists should do. And as I mentioned earlier, that a lot of the manuscript I review, they keep adding new elements to a very simple model and then twists and turns. And yes, we can get 95%, 99% accuracy in model performances, but the model cannot be transferred to another location and it will be tied into a particular case. That doesn't help us to understand what is going on in reality. So I would encourage you to actually analyze, use spatial framework to find out what are the elements in your marine carbon sink domains, and how that element tie into different land use type or different land use zoning. When you come up with that framework, then think about how the process that connect different elements to each other, what is the underlying mechanisms, then think about what will be the method will be appropriate, help you to solve that problem. And I think that don't think about the method first, think about the problem first. So that we don't put the car in front of a horse in some way, right?
The cart, yeah. Then I raised my hand myself, and I want to ask a question, or maybe I'll raise some ideas. So I think I really appreciate your introduction of that concept called specializing data. So I'm a data scientist. I always think about starting from data, the training data. So how much we can enrich our training data with the spatial thinking spatial concepts. For example, we use a lot of social data. We also can think about how much we can spatialize social distance. So for example, we get into some data with the entities with the social distances. So for example, this the data coming from a network and could be a classroom, professors and students, and students working in the same team. So these will be the new data dimension we can introduce to help improve the model. So is this one example that you meant by specializing data or adding more dimension to the data? So second thing is, so I'll let you answer this question first, and this is what you meant by specializing.
Yeah, so in the simplest case, that when we input features to the machine learning models, it doesn't matter which machine learning model, the feature itself is a vector. So we already specialize the data. So even we don't realize we specialize data, we are specialized the data, because that's how the model works. And the I think that my question to myself right now is, I'm so biased towards the specialization, specialized data. Can I come up with an example that we actually do not spatialize the data in our machine learning AI models? And I haven't yet come up with an example.
Theoretically, no, and everything is specialized in that process of model specification of features. So my point is,
I think the challenge is that when we spatialize it, we basically every features will be part of the axis in the feature space, right? In the feature space, we have to make sure that each axis have the same unit of length, have the same range, so that they are, all the features are in the equal footing. So for example, like housing prices and number of rooms. The number of rooms could be just one, you have 2 bedrooms or 3 bedrooms and maybe plus a kitchen. So maybe the most number of room in a house can be only 10. But the housing prices difference can be at the range of millions, right? The most expensive houses and maybe $100 million, but the cheaper houses could be only $100,000. So the range of the housing prices is really high, but the number of rooms differences are very small, and therefore we have to standardize the range for all the features. Maybe everybody is from 0 to 1, and or based on the normal, assuming normal distribution or log distribution, to scale the data. So it's not just a direct specializing the data, but also have to adjust the axes in the multidimensional space.
Yes. Yeah. So that's the promise we think about. For example, our data are assuming they could be spatially independent. Yeah, but actually they are not. So think about this: if temporal data, time series data, we do not assume that the temporal independence. So in other words, we have to pre-process the data or explicitly model that temporal dependence. So that means we can also think about this and with the spatial dimension, not necessarily geo-co-dependency. And it could
Oh,
be in any scale, for example, social distance or a professional distance and hierarchical distance. This could be enter if that could be spatially factor or spatially considered. So that will make the data much more useful. And is what I'm saying. So we go beyond just spatial, but everything is spatial in your sense,
yeah.
right?
Well, that's my bias. Even I think temporal is spatial, because think about a
Yeah,
lot of
yeah, that's
when we
right. Yeah,
describe time, we use spatial metaphor,
yes,
right?
exactly,
So
exactly.
I actually when my dissertation is when I first studied GIS, I actually studied time, and
Yeah,
then I
yeah.
read a book, the brief history of time, and the book said time doesn't exist. Time is a artifact, our imagination. But that is
uh,
written by a
Save it
physicist.
for later.
So that's right.
Yeah,
That's right. That's a different
later argument. Yeah,
discussion.
yeah.
And then so I think that in GIS, I think one of the students mentioned Moran's eye, spatial autocorrelation. But in spatial statistics, it's important to think about spatial autocorrelation
Yeah,
when you do
yeah,
the interpolation or do the
yeah,
spatial pattern analysis. But
yeah.
actually, in the algorithm, in machine learning or AI algorithm, it actually doesn't matter as much spatial autocorrelation. They actually you take advantage of a spatial autocorrelation to find the patterns. The just think about all those axes, right? And the axes do not need to be orthogonal or perpendicular to each other.
Yeah.
If they are independent, all the axes have to be perpendicular to each other. They cannot be at an angle.
Yeah.
But in a multidimensional space, it is okay to have those axes at an angle. And the other argument for in the algorithm stage, spatial autocorrelation is not a big concern. It's because we have all the data coming in. The machine learning and AI taking massive amount of data. So it doesn't consider the data are representation of population in terms of statistics. Right? In statistics, we collect samples, and then we want to prove that the sample is representative
The
of the population. But in
population.
machine learning, you actually consider that all the input data is approximated to the population. So if the data is approximate to the population, then in the algorithm stage, the autocorrelation, either spatial or temporal, is not an artifact. It's some property that important for making a prediction. Because AI and machine learning is trying to make prediction. They need to have that autocorrelation to make the prediction.
Yeah, I understand that regularization concept. Like you can string the data is not that is nothing about the collinearity. what I was referring to is adding additional dimensions by spatializing the data. For example, you collect data about individuals. So then you can use survey data, then put it into the model. But there could be ways we can make additional dimension or additional features. You can consider features too. So think about this. That matrix is representing the connections of these individuals, or not necessarily real, pure probabilistic connections. Think about this. Or you're I live in Flower Mound, and maybe people like me living in Flower Mound have some kind of connections. So that could be considered. That the data could be easily collected if that is something that then can add to additional dimension of the data. And I'm thinking that it's actually extending your spatializing data concept to make training data to be more, adding more features, adding more information for to feed for the algorithm for the prediction. This is something what I want. What I want to explain. So there will be something in future, hopefully, and we can get into that. So let me. There's one follow-up question. Yeah, you follow up too.
Yeah, I can say the Seth questions. I want to make it very clear that if your training data is not sufficiently large, then you do need to worry about the spatial or temporal autocorrelation in the data input. But if your training data is massive, that you can argue that your training data approximate the population of your study, then you don't need to worry about spatial or temporal autocorrelation. But if I think the most of the study I have seen from the GIS or social scientists, I think is the input data is not sufficiently large. For example, for GIS, a lot of study just for a given city, but there are a lot of cities in the world. Your city may not be approximate any other cities in the world. So if you just have all your training data from one city, and that is not going to be sufficiently large to approximate that population of all cities in the world. In that case, you do need to worry about in the data pre-processing, get into the machine learning model. You do need to consider data cleaning, autocorrelation, and all other issues. And just like last time we talked about silicon samples, and I will be very curious that when you have like election samples from silica samples, and different people in rural area, in urban area, they might have a very different voting behaviors. So if your silicon sample only based on the age groups and gender or income, and you do not consider the geographical locations, then the model predictions will be pretty questionable. That silicon sample is not sufficiently approximate the population that you try to make prediction about.
Yeah. All right. And do you have more questions from Taiwan side, maybe?
Yeah, I got a few questions here. Maybe I'll just put them together. Okay. The inclusion of spatially intelligent models in robotics, autonomous vehicles, and decision support systems are our interests in public sector. Yeah, so let's move a little bit away from the time and space things and the smart governance applications. So what are the current bottlenecks in scaling these AI models for wide-scale deployment in government services? I mean, this is one. And the other, I think is related, is that can you provide examples of successful pilot projects using spatial AI in public governance or city management? It's more practical perspective.
So,
Yeah.
so I would think that a lot of the electric grid, for example, that is very much apply the AI to control, to first detect where are the power outage or the electric grid. They might have like a line break or to detect the automatic detection of those defects and the water resource management and also use quite a few AI applications and it's geo AI because they're also looking at the spatial locations and it predict where are the junctures that are the weakest link, for example. And in the city government and local government, as I observe here in the United States, I do not know other countries, is uh, uh, they are tied into like smart cities and the digital twin is in the current trend right now.
Yeah.
What digital twin will do is to be able to ingest real-time data so they can anticipate any problems coming so they can prepare accordingly. The another element of AI that I observed that people starting to use in the government agencies is really combine the natural language user interface with GIS software so that you don't need to worry about to find which tool to use. Rather, you just tell the system of what you want to do, and the system will convert your natural language input into a workflow and then return the data to you. So like I want to create a map that show median income distribution in Taipei City. And then you just tell the system that's what you want and it will create one for you. And that is getting more and more popular in the local government because the software is now part of that software interface.
Okay.
And then digital twin now used in a lot of airports. Like my former students in Dallas Fort Worth Airport, they are building a digital twin of the Dallas Fort Worth Airport. The city of a lot of cities and start building the migrate from smart city infrastructure to the digital twin infrastructure.
Okay. And I think this is related to the other question asked about the most significant obstacles in integrating spatial thinking into machine learning models for real-world policy and the governance applications. So the obstacles at the point.
Well, that is a really good question. I think that unfortunately, spatial thinking have not been an emphasis in the public education. and I think it's worse than Taiwan because here a lot of high school students don't take geography courses. And so I think that the challenge of spatial thinking is number one, people don't know what this spatial thinking is. And number two is that a lot of people actually have trouble to think spatially. Give you an example. Some years ago, I have a project with a private company and on the Department of Defense project. And the meeting is in DC. My collaborator, and he worked for the company, is a computer scientist. Is in DC. So I flew to DC, and then he picked me up at the airport. At that time, there is no Google Map yet, but it's like a navigation system. So what he did is that he just print out the turn by turn in natural language, and then he followed that turn by turn to take me to the meeting place. I said, well, why don't you just print out a map? For me, it's just so much more comprehensive If something goes wrong, I know the alternative route. But he said he cannot remap. It doesn't make sense to him because they have to orient it to the street orientation. He doesn't know he's driving towards north or driving towards east. He doesn't have a sense of a orientation. So for him, the turn-by-turn direction makes more sense. But you can think recently, now we all follow the Google map or Apple map when we navigate to a city. We actually do not practice our spatial cell system. And one of the experiments we try to do is to see that how people constantly use navigation system versus the one that who do not use navigation system, how their brain development might be different in that spatial cell system area. And if that is true, just like a calculator, now a lot of our students cannot do simple math because everything will defer to the calculator. And very soon that maybe, maybe nobody can know how to read maps. Nobody use their hippocampus area anymore. And but I think the challenge is that the area also store social relations and the temporal relations. So whether that will also degrade our ability to reason through social interactions or time temporal reasoning, I don't know. It's all up to guess right now.
Mm-hmm. And I think this is also important, during the transition from perception AI to agentic AI and the physical AI. I think these elements are very important, right? So, yeah. Okay.
Yeah. I agree with you, of course. I'm biased. Spatial thinking is important.
Yeah.
We are good students. I learned from you now. Yeah.
Any other questions?
All right. Do you have any questions from your side? I think I do not have any hands as of now. And this is actually quite close to the closing time. And 9:51, we have a really, really good turnout today. And a lot of students from South Korea, Taiwan, and I'm sure we have some students from US. Yeah. And I think I would just ask one more round. And to see any more questions, we can pose it to Professor Yuan. And then I will have some announcement to make. Let's see more questions. And
I also welcome you to email me questions. I really want to learn some from you and you all. As I told you that I don't have much knowledge outside GIS, and please help me to learn more.
That's a lot. And is it okay I post your email address to the chat box?
Oh, yes, of course.
Yeah, let me go ahead to do that. And let me go ahead to put in chat box, and I can read it out if you do not have it with you. Access to that. It's a very simple myuan@utdallas.edu. So that is Dr. Yuan's email address. Now, I think if you have no more questions, we will have one more finale of the colloquium. So we will have Dr. Patrick Brand and giving another talk of the colloquium that will be after the Thanksgiving break. So let me put it on the chat box also. And Dr. Brand will cover a really interesting topic to me. I think it's a very important and new topic. It says title Extractive versus Generative Language Models for Political Conflict Text Classification. So that is one of the topics I really anticipate. I'm really privileged and I'm really glad that we have Dr. Brand giving one more presentation for the colloquium of 2025. This will be December 4th for the US audience and December 5th for the Taiwan audience. So please join me, and you can click on that and register, or join me and for that event. So I think, Peter, do you have any concluding remarks?
Yeah, I think today it's quite a success because we draw attention from other universities, and also we have
Other
as I
countries.
noticed as I noticed some faculty members from other universities joined us too. So I think
Wow.
Professor Yuan, you attract them here, and then
Yeah,
and
big
then we're
fan
happy to
base.
see that. Yeah, we're happy to see that this is a platform that we can convene or scholars or people interested and to share things. So this is why we started this initiate this colloquium in the first place. So I think it's quite a success. And please do register. And here Carl has posted the registration link. So please do that so that you'll receive the link so they can join us for our finale for this season. So I want to thank you all for joining us today, and especially thanks to Dr. Yuan. And then I hope that we have the chance to invite you back and to hear about maybe time is illusion.
Yes.
Time is illusion.
Time is elusive.
Yeah.
All right. Well,
Okay, thank
thank you
you.
all.
Long
Thank you
space.
for the opportunities.
Mhm.
Okay.
All right.
All right, thank you all.
And bye-bye.
Good afternoon in Taiwan side and good night for the US
Yeah,
side. Thank you all.
good
Thank
night.
you.